Hi, so today we're going to talk about the next lesson, which is about sampling and sources of bias. So probably we've talked a little bit about bias here and there. Today we're going to get more into it. So we're going to identify sources of bias that may exist in specific surveys or sampling techniques, and then we're going to discuss the effects of bias in a sample or a survey. So let's start by talking about what bias really means. So bias means it's a systematic inaccuracy in measuring the estimate. So that means it's a consistent inaccuracy that occurs kind of in the same direction every time. There's something that's pushing, in a sense, answers to one direction. So why do we care? Well, we can't really do anything with bad data. If we have data that is biased, there's not really a good way to fix that. So there's nothing we can do with it. It doesn't really tell us anything about the population. We're kind of just stuck. So it's like we've wasted our time. Garbage in, garbage out is a common saying. If we're taking bad data in, any results we get from that data is going to be flawed. So bias is not necessarily the same thing as what we call sampling error. Sampling error is a term we use for just variation in a sample. That's going to happen when we take samples instead of looking at the entire population. We're always going to have a little bit of variation or error, meaning that there's just some wiggle room there. So just to kind of show you a visual of what we mean by that, we have some dartboards. So this one in the back or on the left side is a situation where we had a lot of bias. So we can see that the points are all, or the darts all landed pretty close to each other. So whoever did this is really good at dart throwing, but they were, for some reason, their darts were going off in the same direction pretty much every single time. So they were very good at what they did. There wasn't really much error or variability, but they were off. The one in the middle represents variation, right? So they were clearly aiming towards that center circle, but they weren't very good at dart throwing. So the darts kind of had some variability. There was some error there. So that's kind of the big difference between bias and variability. The one in the front or on the very right side would be one that has very little bias and very little variability, which is of course the goal with a sample, is that it has very little error, very little variation, and very little bias. Today we're going to talk specifically about bias. Throughout the year, we'll kind of look at ways that we can decrease the amount of variability in our samples as well, but just know that those are two separate things. So we're going to talk about all kinds of different scenarios that would cause bias, starting with the way that we take the sample. A lot of bias can come from just the way that we take our sample from our population. So the first one is what we call voluntary response bias. So this would be a situation in which we put our poll out there for anybody to answer and people choose to respond. Right? The problem there is that when people choose to respond, usually only people with really strong opinions are the ones responding. So we get these answers to our survey or our poll that are off in one direction usually, because only people with very strong opinions, usually in one direction, are the ones responding. So just to give you an old example of this, which you could probably think of many examples in the last year and a half that have voluntary response bias, but just an old example. So Ann Landers was a newspaper columnist who asked, or a radio show host who asked her followers or listeners, hey parents, if you had to do it over again, would you have children? That was the question that she put out there. 10,000 parents responded, and 70% of parents responded saying, nope, kids are not worth it. And this was a cartoon that came out pretty recently afterwards. And hey, Pops, what's that letter you sent off to Ann Landers yesterday? So a lot of parents responding and saying, no, I wouldn't have kids again. But this is what we call a voluntary response survey. She sent it out there for her listeners, and whoever felt like it responded. So who responded? Probably a lot of the parents who had a really rough day or year or whatever. So they did a new survey where they actually use a random sampling method. Gallup is a really common survey place, and found that actually 90% of parents were happy with their decision to have children. Right, so this is what they look like. So when we take a random sample, we're getting an actual sample that's representative of the entire population of all parents versus just putting it out there for whoever feels like responding and getting something that's very biased. So that's one way that we can have bias in the way that we take our sample. The next way is with what we call a convenience sample. So a convenience sample basically means we ask people who are easy to ask. We, as the survey takers or samplers or pollers or whatever you want to call us, just ask people who are easy for us to get to. There's really no attempt at randomness. We're just kind of going out there and asking whoever is easy for us to get to or easy for us to reach. Right. So for an example, if we were trying to find the proportion of students at McNeil who have a part-time job, and we stood at McNeil's side entrance where the buses drop off and ask students as they come in off the buses, right? So we're dealing with people who mostly ride buses. So even if we try to be, selective about who we pick, we're still getting people who ride buses, and people who ride buses typically don't have either cars or driver's licenses. And if they don't have cars or driver's licenses, it's a little harder for them to have a part-time job. So we're getting very varied answers. We're getting answers that are not necessarily representative of all students at McNeil. We're really only getting people who don't drive. And that's going to bias or add bias to our sample. Another way that we can have sample or bias in the way that we take our sample or get our sample is non-response bias. And this occurs when an individual is chosen for the sample, but either can't be contacted, refuses to cooperate, maybe forgets to respond. This one feels very similar to voluntary response bias, but it's a little different in that we do, as the samplers, as the pollers, as the survey, as the statisticians, we do actually pick a sample, maybe even pick it randomly, and are trying to be really, really good about getting a representative sample. But for some reason or another, part of our sample doesn't respond. So we end up with usually very biased answers. The reasons that those people don't respond cause us to get one type of answer more than another. So for example, a company randomly selects 100 of its regular customers and calls the phone numbers listed in their profiles to survey them. Only 72 of those customers answer their phones, and only 34 are willing to participate in the survey. So we have 100 customers that they randomly picked trying to get a representative sample and only ended up with 34 actual responses, right? The 34 people who had time to respond and who felt like responding to whatever the company was asking probably have very different opinions from the people who either weren't at home when they've called or didn't have time or didn't feel like responding, right? So we're missing out on part of that population because we are pigeoning these people who want to respond. So again, it feels very similar to voluntary response. The big difference is, did we actually pick a sample and they couldn't respond, or did we just put it out there for anybody to respond? So kind of looking at that first step. Like I said, they are chosen by the researchers but do not participate. They're not self-selected. So with voluntary response, we say that the sample is self-selected, meaning that they choose themselves to reach out and respond. Right. A last word that we have when we're talking about bias in the sampling process is this word undercoverage. And undercoverage is basically a general word that means that some groups of our population of interest are left out of the sampling process. So even if we take a random sample, from just part of our population and leave out other parts, we're going to get a biased sample. This generally happens as a result of a bad sampling frame. So sampling frame is the word we use for who actually had a chance to get picked in our sample. So even a random sample taken from a sampling frame that is not representative of our population could lead to undercoverage. So I'm going to show you a little visual to kind of demonstrate what we mean by a sampling frame as opposed to a sample or a population. So let's say this yellow circle represents our population of interest. This is who we want to find out about in this particular problem. And let's say this white circle represents the actual part of our population that I took my random sample from. So notice that that white circle is not the entire yellow circle. So even though population of interest was this entire space that's yellow, we only took our sample from this section that is white. And then of course our sample is just going to be part of that. So now we have this. So that's kind of a way to look at the population versus the sampling frame. In a perfect world, the sampling frame would be the entire population of interest. That should be what happens, but it doesn't always work out that way. Oftentimes we are limiting our sampling frame just to make things easier or whatever, and we end up with a sample that's not super representative, even though we take a random sample. So that's something to keep in mind too. An example of that is actually, this is the example that we looked at on the very first day of school in class. We talked about this one about GPA. So a research group, which is to know the mean GPA of all students at McNeil. To estimate this, they take a random sample. So they do a good job of taking a random sample, but they take their random sample from all first period classes in the A wing. So they're only looking at students who have first period in the A wing. So their sampling frame is students who have first period class in the A wing, right? So because of that, their answer they get from that sample of 189 students for mean GPA might not be accurate or representative of the whole population. Even though they took a random sample, their sampling frame doesn't include everyone in the population, so we might be limiting, right, our sample. It happened in the past when I first wrote this problem that a lot of A-wing classrooms were like freshman classrooms, so it would kind of make sense that freshmen's GPAs would maybe be a little bit lower than seniors' GPAs, and that would end up with a sampling frame that's a little bit off from what it should be. Okay. So, big question is, could bias be unrelated to sampling? The answer is yes. We can have bias that is not related to the sample or the sampling process at all. It could be related to what happens after we take the sample, which is when we do our data collecting, when we do the survey, when we ask the questions, when we figure out what our data is. And that is called response bias. So response bias refers to anything in the survey design that influences responses. So that could be that whoever's asking the questions is clearly biased or maybe even intimidating, that is leading the people's answers to be in one direction or the other. Okay, so let's say if your boss conducts a face-to-face survey about how Your boss conducts a face-to-face survey about job satisfaction. So if he's just right up in your face, how do you like your job? Your answer to that is probably going to be a little bit biased towards the direction of, oh yes, I love my job. If you're intimidated by your boss. Could just be untruthful responses. People lie and they have reasons for lying. It could be interviewer bias, but it could just be that they're untruthful people. So as part of a community safety survey, drivers are asked how often they speed. Most likely we're going to get an answer that's not necessarily representative of the truth, because people lie about things like that. The wording of a question, it could be either confusing or it could be very leading in one direction or the other. So confusing is part of a survey on student academic confidence. One of the questions asked, has there ever been a time where you didn't think you wouldn't fail? It's very double negative-y and it's very confusing. So do I answer yes or no to that question? People might be answering one way when they mean to answer the other way. So we end up with survey results that are biased. And then the question could be leading. It could be very clearly leading towards a specific answer, and people may not answer truthfully because you've kind of led them to a certain response. So if I asked you individually as a class, hey, you've never cheated off someone's homework, have you? And you'd be like, no, of course not, Miss Calvin. Kind of falls into interviewer bias, intimidation sometimes, or just untruthful responses. But the question itself could be very leading that would guide someone to answer a certain thing. Okay. So, for example, in spring 1993, the Holocaust Memorial Museum opened in Washington, D.C., and a survey was conducted by Roper Starch Worldwide, which indicated, or seemed to indicate, that 22% of the American public believed that it was possible that the Nazi extermination of the Jews never happened. And that's just a little, another 12% were unsure if it happened or not. And that just seems a little bit off. Like, yes, there's some people with conspiracy theories that are kind of out there, but this seems like a big percentage of American public who believe that. So they looked closer at the actual survey that was being taken. This is the exact wording of the question on the survey. Does it seem possible or does it seem impossible to you that the Nazi extermination of the Jews never happened? So there's a lot of, again, kind of double negative, a lot of words that made it more confusing than it needed to be, and that led people to answer yes when they meant no, or no when they meant yes, etc. So they did a new poll. Gallup, again, is a company that does a lot of polls and surveys. And the new poll question says, does it seem possible to you that the Nazi extermination of the Jews never happened, or do you feel certain that it happened? That clarification of what they were asking and what answer means what led to less than 1% said they thought it was possible that it did not happen. So that's a big difference from the 22% and 12% unsure to now less than 1% saying they thought it didn't happen. Another example, in January 2006, the New York Times asked a sample of 1,229 adults one of the two questions following. So the first question said, after 9/11, President Bush authorized government wiretaps on some phone calls in the U.S. without getting court warrants, saying this was necessary to reduce the threat of terrorism. Do you approve or disapprove of this? And in that question, we had 53% of respondents saying that they approved. The other form of the question, the other half of the survey got, said, after 9/11, George W. Bush authorized government wiretaps on some phone calls in the U.S. without getting court warrants. Do you approve or disapprove? And on this one, only 46% approved. So just that slight change in wording, calling him president versus George W., and then giving a reasoning of why versus not giving that reasoning led to a pretty decent drop, majority versus not a majority in percent approval rate. So it makes a big difference the way we word questions and the way we ask them. So we're going to look at a few examples where I want you to think about what type of bias might exist in this sampling process. Remember, it's more than just naming it. It's really thinking about how you would explain it or interpret it, which we're going to talk about in the very, very last slide of this lesson. So in this example, before the presidential election of 1936, FDR against Republican Alf Landon, the magazine Literary Digest sent out 10 million questionnaires to potential voters, of which 2.8 million were returned. Based on the data collected, the magazine predicted Landon to win the election in a 3-2 victory. So thinking about what type of bias is happening in this situation and what it might cause the results to be. So I'll give you a second to think about it. So this would be an example of non-response. So they sent out a survey to 10 million questionnaires. So they did actually pick 10 million voters that they wanted answers from, but only got answers from 2.8 million of them. So less than 30% of the actual surveys were returned. So the sample is not super representative of all voters. And you might think about what types of people are less likely to return a questionnaire or what types of people are more likely. And also we could get into who actually read or were subscribed to Literary Digest in those times was generally more affluent people who had more money. So that kind of might have led to them to predict what they did. Landon didn't win. We know that FDR did win that election. All right, second one. Suppose that you want to estimate the total amount of money spent on textbooks each semester at UT. So you collect information on register receipts from students as they leave a campus bookstore during lunch one day. So this one, you could kind of say two things. Convenient sampling, right? There was no apparent method of randomness. They kind of just stood outside of one bookstore and collected receipts. It was an easy way to collect data. They didn't have to go out of their way. There was no real attempt at randomness. And then the other thing you could have said is maybe undercoverage, right? This one bookstore at UT is not necessarily going to be representative of all the different ways there are of buying textbooks. People can buy them online. People can borrow them from friends. There's a lot of different methods or even other stores that are not included in the sampling process. So you could potentially also say undercoverage as well. All right, I think this is the last example. To find the average value of a home in Austin, a local news channel puts a poll on their website asking homeowners to report the value of their home. So this would be an example of voluntary response bias, all right? So they put the poll out there for anybody to answer, and really people are choosing whether or not they want to answer this poll, and the home values received will likely not reflect the true average house value for all of Austin. So I put a little follow-up question. Do you think the sample's average will be too high or too low? Probably it's going to be too high. People who report or go onto a thing to report the value of their home are probably proud of how much it costs or like want to brag or whatever. Typically people whose house value is really low may not respond. You may think the other way, but it's good to think about the direction of it too, which is where I want to lead on our final example. One quick note, though, is that in most situations, there may be multiple types of bias present, but it's important to not just name the bias, but to really discuss the bias and its effect on the estimate for what we're trying to estimate, that unknown parameter that we're trying to estimate. So when you are asked to discuss bias, when you are asked on a question to talk about the bias that may be present, you are not just being asked to name by word. It's not just a vocabulary example. You are being asked to discuss it in a bunch of different ways. So we're going to look at some things that you need to discuss in an answer if you were asked to talk about bias in a question. So our three questions are, firstly, what is the parameter we're trying to estimate? Secondly, how is our sample different from the population that we were trying to be interested in? And thirdly, as a result of this bias, will our sample statistic be higher or lower than the true population parameter we're trying to estimate, and why? So we call that direction. So when we're talking about bias, we need to think about what is the actual parameter and who is our population, how is our sample different from our population, but we want to make sure and include direction, which means in some situations you may kind of have to not necessarily guess. There might be problems where you think it could go either way. You kind of have to make a choice and explain that direction as best you can. So, for example, let's say that a McNeil student is trying to find out the mean number of push-ups at McNeil that students at McNeil can do in a minute. They decide to pick a sample of students and have them do as many push-ups as they can in a minute. They know they should use a random sample, so they get to school super early one morning, take a random sample of varsity football players who are standing outside getting ready to go to practice. Describe the bias that would be present in this student's data. So again, the three things we want to estimate are, firstly, what is the parameter we're trying to estimate? So in this example, we're trying to estimate the mean number of push-ups for all students at McNeil in a minute. So our parameter is for all students. Second thing we want to say is, how is our sample different from our population? And be descriptive, be in context here. So varsity football players lift weights and work out more than most other students at McNeil probably do. So that's how they're different. We're dealing with a sample that is not representative of the population and that they lift weights and work out more. So as a result, will our sample statistic likely be higher or lower? We're trying to estimate the true number of push-ups a student can do in a minute, true average. Our sample probably works out more than the population. So as a result, our statistic for that mean number of push-ups will probably be too high because varsity football players can probably do more push-ups in a minute than the majority of McNeil students. So that estimate for the average will probably be too high. So that's a great example of how we can discuss bias. So notice that nowhere in my description did I mention a word. We could probably call this convenient sample. They did use a random sample, so maybe you even think under coverage, right? So under coverage meaning that they don't include the entire population in their sampling frame. We're only including football players. But I didn't really use any of those words. I discussed what those words did to the estimate that I was trying to figure out. So that is how we would discuss bias if we were asked to in a problem. And that is all for today. See you guys next time.